Here we have two scenarios, one of SARS and one of influenza. You can see that the serial interval of SARS is 8 days, while the serial interval of influenza is only 3 days. This means that influenza transmits more rapidly than SARS. And it's much easier to control SARS when we implement quarantine or isolation of cases than it is for influenza. Actually, one of the reasons it was possible to eradicate smallpox, it's because smallpox also have a very long generation time, which is about 2 weeks. And because of that, it was possible to eradicate smallpox. But very short generation time means that we need to identify the cases very, very rapidly before they start transmitting the infection to other people. So the question is how to measure the spread or the transmissibility of infectious diseases, and what influences the spread or the transmissibility of infectious diseases. We have seen two factors already. We have seen the generation time, mostly estimated by the serial interval. We have also seen the latent period in relationship with the incubation. Those are very important elements that influence their transmission, the dynamic of the transmission of infectious disease. But how do we really measure the transmissibility of infectious diseases? I'm sure you are very familiar with epidemiology, and most of the time when we want to measure the frequency of diseases, we use the prevalence, for example, which is the proportion of people in a population who have a specific disease at a single point, for example. For example, here on June 28th, 3,000 children residents in a city were diagnosed with malnutrition, and the total population is 18,000. So if we want to measure the prevalence of malnutrition on that day, it is just 3,000 divided by the population size, which is 18,000. So this is how we measure prevalence and as a way to estimate disease status. And another way to measure the frequency of disease, we use the incidence. We have the incidence proportion and the incidence rate, but the incidence proportion is the number of new cases of the disease divided by the number of persons followed during the period of time. The incidence rate is relatively the same, but we use the total time experience for the subject followed. But both of them generally don't tell us nothing about the transmissibility of a disease. Another parameter is what we call the attack rate. The attack rate is one of the measures of incidence proportion, or it is just the risk of contracting a disease during an outbreak or an epidemic. For example, as more and more people get infected, the attack rate goes higher and higher. So it tells you how many people at the end of the epidemic were infected, for example, developed the disease. But it still doesn't really tell us how transmissible the infection is. So the prevalence is generally for measuring the disease status or the disease burden in a community. Incidence proportion rates and the attack rates are mostly measures of disease occurrence, how the disease occur within a population, but they don't tell us anything about transmissibility. One measure of transmissibility is the secondary attack rates. What is it? The secondary attack rate is the proportion of susceptible who become infected after contact with a primary case. So we need to have a primary case here, and then we need to see how many people who were in contact with that primary case became infected. So this one, they call it the secondary attack rate. This is just an example. In the 2009 pandemic influenza, they were comparing the attack rate between the pandemic influenza and the seasonal influenza. They found that both within the households, the secondary attack rates of both conditions were almost similar. However, the secondary attack rate is really not a perfect proxy for person-to-person transmission. Remember, I said the attack rate is the proportion of those who develop the disease after contact with the primary case. This is the primary case in a household, for example. And let's rule out the possibility that there is no infection coming from outside. Everything is in a closed environment. So 2 people, among the 3, 2 became infected. So the secondary attack rate is 2 divided the total size, 3 of them. So out of the 3, 2 became infected. So this is the secondary attack rate. But how did the transmission happen? We don't really know. There are many possibilities. For example, the primary case can infect both of them at the same time. Or another possibility, it can infect the one here, and the one up will infect the one down. And one other possibility is that it can come from the one down to the one up. So we don't really know exactly how person-to-person transmission happen when we just look at the secondary attack rate. So for the person-to-person transmission, the best measure is what we call the reproduction number. It's a measure of transmissibility, and it also gives us a very good picture of how transmission from person to person happens.